This is the very last session of today's program, and I'll talk a little bit about the dynamic of video in mobile environments. Qualcomm is a chipset vendor and a technology vendor in the wireless industry. So, and because of the smartphone, I believe you see the frenzy of the smartphone, and the major frenzy of the smartphone, behind that is the multimedia, right? Without the multimedia, I don't think smartphone will have the popularity as today. So if you go to either Asia or Europe or in US today, everybody has their own screen, and it's because of smartphone. So you can see 1/3 of the daily multimedia interaction actually happening in smartphone. And you can see the Facebook, they have more than 1 billion subscribers today, and probably more than 60% of them are the mobile. And more and more people in the world, they are going to have access to mobile devices from here. So you can see that's really the trend. And mobile video, or the multimedia, mobile video actually is really behind the scene. You know, according to the Cisco's survey over there, you can see in about 2017, maybe we will see around 70% of the web traffic are purely based on video. So I think video is going to be the future, and is very, very important. And because of the we have millions of subscribers being added into the mobile industry, mobile devices users as a matter of time, and also you can see the contents video contents is available almost everywhere, including the social network, right? A lot of contents were created by the user. And also the device platform, the smartphone, is getting more and more powerful. So like they have a better imaging capability, including video. So video traffic is going to, in that way, like Cisco is projecting. And the other thing is really, you know, but right now the default call, right? If someone call you, the default is going to be the voice call. But if someday the default call is a video call, and then unless you don't want the video call, probably you disable the video and just come to voice only. So around that time, you know, the mobile video is going to be even more important over there. So this is really like a survey based on the ages over there. The question is really, if you are shooting the video, right, using the devices, are you using the camera or you are using the cell phone? So most of the young people, they are using the cell phone. This is the age of the 18 to 24. You know, like almost 80% of them, they are using cell phone. They don't use the camcorder or even digital camera, DSC anymore. But for the older age, probably they have less than 50%. So depending on who you are, actually. But you can see whenever those younger generation, they become older, actually the mobile imaging is going to be even more dominating. Okay, so this data growth driven by the digital video. In the early days, it's not really like in the early 1990s when I was working on the video in mobile domain. The first thing we are working on is a Q-SIP, right? I don't remember any one of you still remember what is a Q-SIP's the resolution is 176 by 144, right? And 15 frames per second in the very beginning. And the processor around that time, you have a hard time to reach that. But today, we are talking about the 1080p 30 frames per second. almost in every single smartphone, the high-end smartphone, you have the capability of that, right, including iPhone. So that's about 160 times of the capability increase over there. And then after that, actually, we see the 4K and even 8Ks, they are coming, right? So another 64X over there. Whenever we go from the 1080p to 4K and then to 8K. And 8K, people is not going to be satisfied with 30 frames per second. So probably they are talking about 120 frames per second. So if you are talking about from the QSIP, 15 frames per second to 8K, 120 frames per second, we are talking about 10,000 times of the increase of the capability and data over there, right? Okay, so, but if you take a look at the video codec evolution, right? Starting from the MPEG-2 and then to MPEG-4, we have about 25% compression ratio over there, like performance improvement, and another 25% from the MPEG-4 to 264, and then 264 to 265, about 40%. So we are talking about like a 3 times over there, the 3x compression ratio. But if you go from the QC 15 frames per second to 8K 120, right? We are talking about 10,000. But so you can see there's a need for the better compression technology over there. But compression definitely will be also bounded by the Shannon theory, right, for the source coding. So there's entropy limitation there. But it's very desirable for us to work on the better compression technology for the video. So this is just one example. If you have MPEG-2, if you have 100 megabyte, and today in 265 main profile, probably you can go down to 33. So, and the other one we were talking about is mobile industry. Actually, I was talking to Alex from video a little bit before this. Really, I think before H.265, HEVC standard, including H.264, AVC, right, and anything before that, the mobile industry was not very active in those video standards. So actually, like in AVC H.264, there's some implementation, there's some algorithm over there that's not very friendly to the mobile platform, right, embedded platform. So, but starting from H.265, actually, mobile industry is in the driver's seat right now. So we are trying, mobile industry is trying to drive the international standards. And also, we, this is in Qualcomm, when we attend the H.265 standard, we want to make sure the standard is really friendly to the embedded platform, right? You have to be friendly to an embedded platform in terms of the power and computation, and also like a hardware and software hybrid implementation over there. So this is really like the trend we would like to see even after the H.265 HEVC main profile. They are trying to get into range extension and maybe even H.266. Or even Google is pushing the VP9 and VP9 evolution over there. We want to make sure it's really friendly to the embedded platform in the mobile domain. Right? So, and everybody, you can see we have our own screen. So you can see most of the digital content is being consumed in the personal screen. I don't know if you use your cell phone. Have you ever experienced like you run out of memory, right? You have to delete some file. Like in my iPhone, I have to delete. I have 32 gigabytes, and sometimes I had to clear up some file over there. And those files, the majority of them are due to a video. Whenever you download the movie, right, 2-hour movie is about 200 megabytes. So that's quite heavy over there. So we are looking forward to the new codec evolution over there to solve some problem over there. And also, you can see the trend of the mobile, right? Today we are in 1080p, but mobile actually is moving into 4K as well. And also, eventually, probably we have to get into 8K because of, we are talking about the second screen, right? So you may use a mobile to generate the contents for even decoding the video and then play it back on the larger screen over there. Okay, and this is a slide kind of highlighting the display resolution. Since the Apple, they have an iPhone 4 with a Retina display, right? After that, all the smartphones pretty much, they want to beat that display resolution. So displays on the smartphone, they are going up from 326 ppi to 450 and 500, you know. And do you really need that kind of resolution? We don't know, but you know, it's really like almost like a checkmark feature was a Retina display in the smartphone today. And this is a picture kind of showing you well, different smartphone, different panel over there, and what is the resolution this eye resolution was a smartphone, and this eye resolution was a tablet, because the tablet is a little bit further away from whenever you are viewing it. And you can see the green line over here. This tablet up to 10 inches, and smartphone probably we are talking about maybe 6 inches. And if you have an 4K screen, you're pretty much okay with a tablet up to 10 inches. You are always above the eye resolution. But for the smartphone, I would say probably you need to have WQXGA in order to beat all the eye resolution within the smartphone's range from 3 inches to about 5 or 6 inches display over there. So you can see that's a display resolution on the smartphone evolving. And the other one is really like I was talking about the second screen. So wireless display is another area. It's coming into play. So you can see the Miracast is one of the standard there being proposed in the Wi-Fi Alliance. And in that, they want to use either smartphone or tablet. And you have to decode, you do the transcoding, right? So you have to decode it first, and then encode it again, send it through the short-range Wi-Fi to the wireless display. So that's pretty much Miracast is expecting. And wireless display, they have a different requirement because the wireless display, you are trying to recording the screen contents. So they have artificial image as well, right? Because you have a text, maybe you have a graphic over there, not only the natural video. So 265's range extension probably is very important for this. So video compression is really a key for the future wireless display as well. Okay, this is one of the slides I would like to spend a little bit time on it. Because we are a chipset vendor, Qualcomm, and we we have to support all the different codec flavor, as well as different delivery format. Okay, so this is one of the area we have to make sure our chipset really support it. And also, we have to make sure our video features can be hardware accelerated with performance and power consumption expectation there. And also, because of the gap between the display and contents, right? And we have to make sure the video post-processing is there, so you can deliver the high quality video, including the like scaling and frame rate conversion over there, and supporting the different kind of operating system and different API is also very important for our chipset. Okay, so this is the very last slide. Mobile video dynamics. In smartphone, 1080p 30 video is pretty ubiquitous. And you can see they are moving up. Right? Eventually, I'm pretty sure maybe 4K will come very soon. And then the next generation imaging format, 4K video, probably we need H.265 high profile maybe, or even the next generation video codec. And visual quality, in the early days, if you have a 1080p video and I don't have it, probably people are talking about, do you have this feature or not? Right? And now everybody has it. So, and display quality is so high, so everybody is talking about the visual quality now. So it's going to be a key metrics, video quality. Internet traffic growth is going to it's going to give them more motivation for the data compression with the new codec, including HEVC and scalable video codec. And this morning, Jen was talking about the VP9 evolution on Google side as well. Those are also very important to see, and they will set the bar higher. And delivery mechanism is another thing, another big item. The dash definitely is coming, right? And you can see the mobile, and when mobile really support 4K for 8K video, you can see mobile and TV, the requirement over there, they converge, right? So actually, the emerging technology like a Miracast and Dia is a discovery and launch. Those are the between peer-to-peer communication, and Apple has the AirPlay. All those technologies were getting more important. And the very last item, I would think high-quality video post-processing will be needed whenever you have a higher resolution screen, so that you can have those legacy contents presented or rendered on your screen with a better quality. So that's about my conclusion for the dynamic of the mobile video.